Hello folks, today we are going to see constant velocity. In many times of motion, the velocity is constant of approximately so. We have some examples. For example, when we are in a fly, we can feel that we are in constant velocity, and because it we are able to walk during the fly. And for example, where we are driving or in a car, we have a constant velocity and we can see it in the speedometer of the car. Okay, in this case we have the same value to speed and velocity, and speed and velocity have the same value. Speed is the magnitude of the velocity. Okay, speed is the magnitude of the velocity. So we have the average velocity and average speed with the same value. Delta x is the displacement, delta t is the variation in the time. So we have x2 minus x1. x2 is the final position, x1 the initial position, t2 is the final time, and t1 is the initial time. Okay, so we have here rewriting here x minus ox 0x. We have x minus 0x is final minus initial position, is this displacement. And in this case we will assume that we have t1, the initial time, o. So we can rewrite average velocity is x minus 0x divided by t. Send this t to the other side, we have this t multiplying, and we have no more average velocity because the velocity is constant, and because it we use just the letter v to show that we have a constant velocity. Okay, so when we have the average velocity equal the average speed, we have a particular situation where we have a constant velocity. Okay, in this special case v is constant. Okay, let's go to see some examples and exercise. Sample problem. We are here in the letter E because we are in a series of videos where we are discussing about average velocity, average speed, and instantaneous velocity. A race car reaches a velocity of 85 meters per second after traveling 200 meters from the starting line. Assuming the car keeps that same velocity, how far from the starting line would the car be after 15 seconds? So we have here this phrase saying, assuming the car keeps that same velocity. Same velocity is a constant velocity. We are here with meters and seconds, so we don't need to change any measurement, and we can use this formula. X is 0x plus vt. So we have 200 meters, the initial position, the 0x, 85 meters per second, and we need just to put the time here, and we will multiply and add the 200 meters, and so we have 1475 meters. So let's go to see some exercises. You can stop now this video and do the exercise 10 and 11. Okay, we are here in 10 and 11 because we are in this series of videos. So I will press the button now and we will see the answer. Okay, so I will now press the button to we see now the answers here. So we have the same formula. We have here 60 kilometers. O, because we don't make sense to use anything different that O or 0. We have here 60 divided for 48, we have 1.25 hours. Okay, it's no usual I use this kind of idea to say about hour, so it's good to me change 0.25 hours to understand how much is it in minutes. We have here a video about this method is called the method link chain conversion method, where we have 0.25 hours multiplied by 1, where 1 is 60 minutes divided by 1 hour. I will cut hour with hour when we have 15 minutes, so the answer is 1 hour and 15 minutes. Okay, 15 minutes is equal 0.25 hours, a quarter of hour. So let's see this exercise here. So we have here a car travels for 1.5 hours in 65 kilometers and travels for 45 minutes with a constant speed of 80 kilometers. So what distance did the vehicle cover? We have x1 in x2, distance, and we will call put the name total distance to x1 plus x2. Okay, let's go to see the first. The first, we have 65 kilometers per hour multiplied by 1.5, we have 97.5 kilometers. Okay, easy way. But we have here 45 minutes, we need to change to hours. Okay, so you use this same method and find 0.75 hours. It makes sense because in the exercise 10 we had 0.25 hours, and here we have three quarters of hour, so makes sense we have 0.75 hours. Okay, so you use this time 0.75 hours and this same formula 60 kilometers. Okay, I will add the values and we have the total distance of 157.5 kilometers.